Hi, my name is Michael, and I was a part of the group who made PCADA, or the Plasmid Cloning Assembly Display application. Other group members in this project were Nick, Jed, and Natalia. The goal for making PCADA was to develop an easier-to-use program that also produced the most cost-effective plasmid design via Gibson assembly. This was accomplished by expanding the functionality of the repository-based plasmid design software, or REPP, which was developed originally by Lattice Automation. This software allowed us to create dynamic cost analysis by comparing the various company models and their prices, while also creating a primer score functionality and visualization of the cloned circular plasmid at the end of the output. When describing the functionality of PCADA, it is important to emphasize our usage of REPP as a platform. REPP allowed us to take an input DNA sequence and through the algorithm match sections of this sequence to other DNA libraries. The algorithm output also gave us a set of options for different vectors that we could insert, different assembly options, such as PCR or synthesis, and the cost analysis. PCADA builds upon this by adding a GUI that makes it much easier for users to interact with different libraries, as well as integrating with mock company APIs with the goal to later use real company APIs such as Twist Biosciences. This allows us to have the dynamic cost analysis that we talked about earlier. We also added a primer scoring functionality, which allows users to have an idea of how easily the REPP output can be synthesized within a lab setting. Lastly, the visualization of the output vector shows a circular plasmid with different fragments and their locations, as well as their cost for each part.
The software architecture for PCADA is shown here. PCADA has two major components, the core REPP module, which handles cost evaluation for the design, and our external support infrastructure. On the front end, the user interacts with an SFML-based GUI to select the parts databases where components of the target DNA sequence will be selected. Currently, the tool supports standard REPP databases, including iGEM, AdGene, and DNA-SU. The user will also enter the name of the FAST file containing the DNA sequence of interest. PCADA treats REPP as a black box. We interact with it via configuration files generated from the Configuration Manager module. This module simulates API calls to different DNA assembly companies, where pricing and construction constraints are queried. Currently, PCADA only supports a mock API, where the calls are mimicked using a local company server. Once the configuration parameters such as costs, construction constraints, and other variables are extracted, the config file is generated and passed to the core REPP module, along with the user's selected databases and target sequence. After REPP runs, the resulting JSON is plotted using the visualizer module, and a supplemental primer scoring is generated, demonstrating how REPP's minimum cost scoring can be augmented with additional scoring metrics.
We use the terminal on the left to call the app. Once the GUI is running, as you can see on the right, use the arrows to select the database between AdGene, DNA-SU, and iGEM. Now you can see that you input an input file to get REPP running in the background. Now, as you can see, REPP is building the input file. 190 assemblies have been made this current moment. Once REPP is done going through the input file, you should see a list in the terminal of the best possible plasmids, along with the score from 1 to 45. Then the GUI will report your building is done. The building should come with an output file and output files from DNA Viewer.
This is one of the outputs from the file we just inputted. So this visualizer, it visualizes a Python library called DNA Features Viewer. This will pop out the annotated sequence, and it's again implemented by the output of the JSON file from REPP. So this will display the cost per fragment. And if it's synthetic, this fragment needs to be synthesized. And if it's PCR, then the viewer will show a URL where you can purchase the template. This is one solution, and then here shown is the second solution. This one uses 5 different fragments and various outputs, and you are able to get this by modifying the components in PCADA. We think this is a cool project because REPP has the ability to generate valid DNA constructs, and we were able to build on this and make it dynamic by including pricing and simulating the pricing from several competing companies that provide these products. This will enable researchers to select their construction and define if they want the lowest cost or if they want a better performance per primer. And we lastly developed a proof of concept of how REPP can be integrated with APIs.